Dear students, welcome to this new platform. Due to the severity of pandemic COVID-19, it is clear that when would be the colleges reopen. So, dear students, utilize your precious time in participating the online classes. Today, in this class, let us discuss about the nomenclature and preparation methods of carbonyl compounds. This chapter comes under third semester for second year students. This chapter is very useful to both competitive exams and all kinds of set examinations. So, nomenclature of carbonyl compounds. I think all of you are very familiar with some flavors like vanilla flavor, cinnamon flavor, almond flavor, etc. Vanilla flavor is due to the presence of vanillin in vanilla beans, and cinnamon flavor is due to the presence of cinnamaldehyde, and benzaldehyde is responsible for the flavor of bitter almonds. Students, the structure of vanillin is like this, and the structure of cinnamaldehyde is C6H5 CH double bond CH COOH. Sorry, CHO. The structure of benzaldehyde is C6H5 CHO. So, do you observe all these compounds contains CHO group? What is CHO group? CHO group is known as aldehyde group. So, all these compounds, all these flavors are due to the presence of aldehydes. These aldehydes in these compounds. Due to the pleasant odor, both aldehydes and ketones are also used in perfumes. You are also very familiar that formalin is used in preservation of specimens in laboratories. What is formalin? Formalin means 40% of formaldehyde. Our girls are also very well known that acetone is used as nail polish remover. Thus, aldehydes and ketones are very useful compounds in our day-to-day life. These carbonyl compounds are also very useful in industries. Students, now let us discuss about the nomenclature of these compounds. So C double bond O group is known as carbonyl group. Both aldehydes and ketones contain this C double bond O group. Therefore, both aldehydes and ketones are known as carbonyl compounds. If two valencies of these carbonyl group are linked with two hydrogens, then this compound is known as formaldehyde, which is the first member of aldehydes. If one valency is linked with alkyl group and other valency is linked with hydrogen to carbonyl group, then this compound is known as aldehyde other than formaldehyde. If two valencies of carbonyl compounds are attached with two alkyl groups, then these compounds are known as ketones. Now let us discuss about the nomenclature of aldehydes. There are two methods to name aldehydes. One method is common system and the second method is IUPAC system. So first coming to the common system. In this system, aldehydes are named after the carboxylic acids which they form on oxidation. The suffix of the common names of acids is ic acid. If this suffix is deleted and the word aldehyde is added, then we get the name of the corresponding aldehyde. For example, so CH3CHO, this is the one aldehyde. If this aldehyde is subjected to oxidation, then acid is formed, which is known as acetic acid. In this compound, if this ic acid, this suffix ic acid is replaced with aldehyde, then it becomes acetaldehyde. So acetaldehyde is the name of this aldehyde. Now let us discuss about second system, that is IUPAC system. According to this system, the names of aldehydes are obtained from the names of corresponding hydrocarbons. In the name of hydrocarbon, if the letter E is replaced by al, then you get the name of that aldehyde. So what is the name, IUPAC name of this compound means the corresponding hydrocarbon to this compound is ethane, which is having, both are having two carbon atoms. So the IUPAC name of this hydrocarbon is ethane. In ethane, if E is deleted and al is added, then it becomes ethanal. So ethanal is the IUPAC name of this compound. Now coming to the nomenclature of aromatic aldehydes. These are of two types. In the first case, aldehyde group is directly attached to the aromatic nucleus like this. This compound is known as benzaldehyde. In the second case, the aldehyde group is present in the side chain. So this is the side chain. What is this compound? This compound is acetaldehyde. So in acetaldehyde, if one hydrogen is replaced with a phenyl group, then you get this compound. Therefore, what is the name of this compound? Phenyl acetaldehyde. So in aromatic aldehydes, the CHO group may be directly attached to the aromatic ring, or it may be present in the side chain. Next, nomenclature of ketones. Again, to name ketones, there are two methods. First one is common method. In this method, the names of ketones are obtained by adding the word ketone to the names of the alkyl groups attached to the carbonyl group. So, for example, if two methyl groups are linked to the carbonyl group like this, then this compound is known as dimethyl ketone. Next, the second method is IUPAC system. In this system, the name of the ketone depends upon the name of the corresponding alkane. So, what is the name of this compound? IUPAC name of this compound means here you have to write the corresponding alkane to this compound. So, this is the corresponding alkane to this ketone. What is the name of this alkane means? It is here three carbon atoms are present, therefore it is known as propane. Now, if you remove this E and add al, then we get propanal. So, propanal is the IUPAC name of this compound. Now, let us discuss about the nomenclature of aromatic ketones. So, this is an aliphatic ketone. In this aliphatic ketone, if one alkyl group or both alkyl groups may be attached or replaced by aryl groups. If one alkyl group is replaced by aryl group, then you get this kind of ketone. This is known as alka-aryl ketone. Example for this kind of ketone is if one phenyl group is attached to the carbonyl group and one methyl group is attached, that means one alkyl group and one aryl group are attached to the carbonyl group. Therefore, this is known as alka-aryl ketone. Therefore, what is the name of this compound? This group is aceto group and this is phenyl group. Therefore, the name of this compound is acetophenone. Next, if the second case, if both alkyl groups are replaced with two aryl groups, then this compound is known as diaryl ketones. For example, if both phenyl groups are attached to carbonyl group, then it is known as diphenyl ketone or benzophenone. So this is about the nomenclature of both aldehydes and ketones. Now let us discuss about the preparation methods of carbonyl compounds. So first preparation methods of aldehydes. There are number of methods for the preparation of aldehydes and ketones, but only a few methods are there in our syllabus. So let us discuss about the preparation methods which are in our syllabus. So first method is Roserman reduction. So from acid chlorides, you can prepare aldehydes. In this method, acid chlorides are reduced with hydrogens in the presence of palladium catalyst supported over barium sulfate at 140 degrees C. So acid chloride. So what is the general formula of carboxylic acids? This is the general formula of carboxylic acid. Here, if this OH nucleophile is replaced by Cl group, then you get acid chloride. So this is acid chloride. If this acid chloride is reduced with hydrogen, then you get aldehydes and HCl. This reaction takes place in the presence of palladium catalyst supported over barium sulfate. In quinoline. Here the function of barium sulfate is to reduce the activity of palladium catalyst. So if the activity is not reduced, if the activity of palladium is not reduced, then the aldehyde formed here, it further undergoes reduction, and then we get the further undergoes reduction, and the final product will become alcohol. But our desired product is aldehyde. Therefore, we have to stop at this stage. We have to stop this reaction at this stage. Therefore, in order to prevent the further reduction, the catalyst activity is reduced reduced using this barium sulfate. So this whole reaction is known as Roser-1 reduction. Next, the second method for the preparation of aldehydes is from 1,3-diethane. This compound is known as 1,3-diethane. It is a weak acid which contains two weak protons like this. If this kind of weak acid is treated with very strong base like N-butyl lithium, then N-butyl lithium reduces this compound. Therefore, 1,3-diethane loses its proton and converts into 1,3-diethane anion like this. And N-butane is formed. Now, if this 1,3-diethane is treated with alkyl halide, then you get alkyl substituted 1,3-diethane, which is known as thioacetal. This thioacetal, on further treatment with H plus and HgCl2, it gives aldehyde. Here 1,3-diethane is regenerated. So these are the two important methods for the preparation of aldehydes which are there in your syllabus. Next, coming to the preparation methods of ketones. Ketones can also be prepared from 1,3-diethane. The only difference is in ketones 1,3-diethane is treated with 2 moles of N-butyl lithium and 2 moles of primary alkyl halide. So if 1,3-diethane is treated with 2 moles of alkyl halide, 2 moles of N-butyl lithium, then both these hydrogens are replaced, and when it is treated with 2 moles of alkyl halide, then 2 alkyl groups are substituted like this, so that we get dialkyl substituted 1,3-diethane, which is known as thioketol. If this thioketol is treated with H plus and HgCl2, then we get ketone. In this reaction also 1,3-diethane is regenerated. Next, another method for the preparation of ketones. Now coming to the second method, from nitriles or cyanides. When nitriles reacts with Grignard reagents, then initially an intermediate compound is formed, which on further hydrolysis gives ketones. So what is the general formula of Grignard reagents? Or MgX is the general formula of Grignard reagent. And what is the general formula of nitriles? Or CN is the general formula of nitriles. This CN group is a highly polar group due to the high electronegativity of nitrogen. Therefore, nitrogen, it withdraws electrons towards it. Therefore, it gets partially negative charge, and this carbon gets partial positive charge. Magnesium, it is highly electropositive. Therefore, it gets positive charge, and this alkyl group gets negative charge. Now these negatively charged alkyl groups attach to the positively charged carbon, and this positively charged bond goes to negatively charged nitrogen. Then we get an intermediate compound like this. So here Mg export is attached, and here alkyl group is attached. So this is an unstable intermediate compound. Now this unstable compound on further hydrolysis gives ketones. Here 1 mole of water reacts in this fashion, and here hydrolysis takes place here also, so that you get ketone. And ammonia, 1 mole of ammonia is also formed. Next, third method, from carboxylic acids. Ketones can also be prepared from carboxylic acids. Say for example, when 2 moles of acetic acid is passed over MnO2 at 300 degrees C, then 1 mole of water and 1 mole of CO2 are eliminated, and we get acetone. So this is about the preparation methods of aldehydes and ketones.